stuff down. And however I do it, I do it. So. Like when I was looking for job for like 2 years ago, something like that, I was like, everything had to be remote.
So you want a remote?
Yeah. Like I could not imagine like not being at home. For me, I really like it, but I understand people are mixed when it comes to that.
A fokus masz na nim dobry? Bo ja teraz wyłączyłam autofokus, żeby tam nie mrygało, jakby ktoś bliżej podchodził.
Oh, this would be interesting.
Bo ewentualnie
It's kind of
mogę
fitting
przysłowy
because I'm trying to build like a search engine,
bliżej, żeby było jaśniej.
like in Poland, just specifically for Poland. So it's kind of like a very good.
Jeszcze raz?
So my personal project right now is just to learn Elixir and stuff like that. I decided to like learn like how to build like a search engine, you know. And
so you mean this Torus?
So yeah, I'm very happy with the topic, you know. So it's a really nice match.
As far as I know, it's more about searching inside the LDB using your various methods.
Yeah. I mean, yeah, for sure. But I guess my idea is that Google is like it gives you really fast results, but it's not complete, right? So if you can scan every single website in Poland, you can like know, okay, where are all the channels? Give me all the channels, and it may take like 4 hours to go through everything, but you get the complete result, you know.
Right now, I think I'm I don't know if you use Perplexity or
I use Cloud mostly. I tried to play with Cloud.
Okay. I think Cloud is great for working with it as an assistant. But for searching or researching, I found Perplexity much better.
Yeah.
Because it basically starts with a search and then compiles the results. But by default, it tries to just figure it out. Itself, and then you search only in special cases.
I like that it's based on the search. Like I tried it for some time where when it comes like everything has sources, right? So I like that part, but like I'm more looking for like a complete result. Because I'm only scanning Poland, like every website.
Hi everyone, we are waiting for latecomers, so 10 more minutes and we are starting. Thanks.
Incomplete, so when you're looking for charity, for example, you want to have all of them.
Yeah. So for example, grants that are issued, because my wife and me, we wanted to start a non-profit, right? And we were like, we were using Cloud or something like that to start like, okay, what's possible when it comes to grants or like support or something like that. But it's kind of like, you get some, but you do search again and you get some more, you get search again, search some more. So what if like you have all the websites, you just search for grants, and then you run AI for every single result to give you, hey, give me a list of grants this year. And then you have like a complete list of every grant.
Maybe in this case there would be some government databases. So I found that I guess they are all registered in some way.
No, but it's one of the use cases. So it's not like, I know there are like some databases, there are a lot of data like they have this data bank, whatever it's called. It's like you can search for population, you can search every single company. So yeah, it's kind of I don't like the fact that you search and you get more results.
Well, since we are all waiting, here are the beers behind you, and there is the kitchen behind this wall. So if you want coffee or a beer, then help yourself, please. Also, the toilets are behind this wall next to the elevators. So if you need them, just go as you get here.
Oh, that's a fun story because I know the Elixir developer.
Oh, really? Okay.
Yeah, so I'm just doubling a bit on my side, but I organize Kraków Ruby user meetups.
Okay, okay.
So I'm a Ruby developer by day, but yeah, I'm interested.
Oh, you're exploring the other side.
Yeah, exactly.
You know, like, we did not, you know.
Yeah, my plan was to talk to Joseph to encourage him to come to Ruby Meetup to give a talk about Tideway Web. But unfortunately he won't be here, so
Alright, that's cool.
Do you work with Elixir daily?
I have my personal project that I started. So, like a couple of months ago, I started like this project, and I just wanted to explore different because I'm mostly Go and TypeScript.
All right. Welcome to another edition of Elixir Community Kraków Meetup. It's very nice to have you all here. This edition of the meetup is kind of special because it's a part of Global Elixir Meetups, which is an initiative organized by Software Mention, which brings together all the meetups, all the Elixir meetups across the whole world. So there are over 40 meetups around the world during this week, and most of them are live streamed. So you can watch them at globalelixirmeetups.com, including our meetup, but this one we're already attending. We were supposed to have 3 speakers today. However, unfortunately, Jose got some flu and he was unable to come. So we wish him speedy recovery, and we will have only 2 speakers today, unfortunately. Anyway, we are going to have these 2 presentations, and after that there will be pizza and networking. In the meantime, as I said, you can grab a beer from the fridge or make a coffee in the kitchen behind me, or use the toilet near the elevators, and most of all, listen to wonderful talks. First of all, we will have Dima. Dima is a software developer at Software Mention during the day. But during the night, he works on a library called Torus, and he's going to tell us how to make search boring with Torus in an exciting way, I hope. So let's welcome Dima with a round of applause.
Hey. Let me let me set this up. So everything should work now. Welcome to, I think it's 21st edition of Global Elixir Meetup, and we've had like 21 stream behind, which is really cool. And I think the initiative is amazing, and it all came up in a big chunk because of amazing work done by Software Mention and developers behind Software Mention. So I think they deserve a round of applause for doing that. Really cool. And today I'll speak about Torus and actually about search. So all applications work around the data, and it's essential to for them to serve this data in efficient and relevant way. And what is a better way of serving the data than letting the users to search through the data, right? So the Torus library focuses on letting you as a developer implement in a really easy way most of search types that you would probably need in your app. And you can do that in a single line of code, and I'll promise I'll show you how to do that. Also, Torus has an amazing documentation about all these search types and where to pick which search type. So you don't need to memorize everything I tell you today. You can just visit Torus documentation, and you will be able to find probably anything you want there. So first, let me start with a little introduction to gain some value in your eyes, probably. So my name is Dima. I work as a software engineer at Software Mention. I've spent almost 4 years working in Elixir. I've started my career with doing some machine learning in Python. I've actually did some recommendation algorithms for literacy portals. It was kind of Spotify for the books, where you fed the books the users read, and it actually outputted the books for them they might like. And then I joined Software Mention, and I've been working on Membrane, which probably most of you are familiar with, which is a multimedia platform. And then I've joined a United States-based company as a contractor, and I've been working there primarily with Elixir for more than 3 years. So regarding the search, let's build an app so we have an example we can derive our things from, and we can actually have some problems to solve. Because I think that if we don't have problems, then we don't need to do anything, right? So our app will be focusing on managing conference talk submissions, but from the organizer side. So our main functionality will be to view, accept, or reject the submissions, or see all submissions. And the first problem we might want to solve is to be able to search by phone number. Phone numbers have this property that semantics of the data live in the characters of the data. Because if you type 1, then there is no chance, or there is really low chance that you meant 2, and only because it's a close on the keyboard. And for phone numbers, we use pattern matching search. So pattern matching searches for a specific pattern in a string. And we have in PostgreSQL, so assuming that most of you use Ecto, Elixir, and Postgres stack, in Postgres we have 3 options for pattern matching. We have like, I like, and similar to. They all differ a little, but they are kind of focused on pattern matching search. And we use pattern matching for when semantics of the data live in the characters of the data. And in SQL, there is a relatively easy way to implement pattern matching. So for example, like coming back to our previous application where we needed to search by phone number, we can implement that relatively easily using just similar to operator and passing the term. Probably we might want to also include some country code, like here. And in Ecto, you would do something like that. So you will have your user. Unfortunately, there is no way in Ecto to single-linedly use similar to expression. So you would need to fall back to fragments. And in this case, that would look something like that. And here comes Torus, where you can actually use Torus similar to, implying that it is similar to, right? Then you pass binding. Then you pass columns that you want to search through. And you pass your term. So this term can be a variable, right? And in this particular example, it is not super helpful because we've kind of reduced only 2 lines of code. But going forward, you will see that we will be able to replace huge amounts of code with just a single abstraction, which is kind of isolated, kind of easy to use, and definitely is well documented. So, and also, the benefit of Ecto, which probably you are all familiar with, is that you can compose, the composability of Ecto. You can compose your queries, you can stack them, you can derive different logic to different parts of the app, and because of that, you can actually abstract away some parts and make your queries look cool. And this is actually what Torus does also. Like in this example, your complex logic can be abstracted away. So the second problem that we want to solve is searching by first and last name. We can't use pattern matching here because you probably can do typos in names, right? And we probably want to catch them, and we probably want to return something back. And for actually catching typos in short text fields, there is a similarity search. So similarity search searches for records that closely match the input text, and it uses trigram distance. Trigram distance works by splitting the word or the sentence into trigrams. Trigrams are sets of 1, 2, or 3 characters. Then they are compared together, whichever, the amount of matches is compared, and in percents they're compared, and then you have a score from 0 to 1. So 1 means exactly all characters, all trigrams match. This is how similarity search works. And in Postgres, we have 3 options for similarity search. We have similarity, word similarity, and strict word similarity, and they all differ by the strictness on how your word is compared in the sentence. So the stricter we are, the less errors we will catch in the sentences. So we use similarity search to fuzzy match and catch typos in short text fields, like full name. And in Ecto, there Actually, I won't provide you an example in Ecto Raw because it is too complex. I will dive deep into the Torus. So in Torus, you could use similar to actually like, or I like, or similar to. You pass bindings, column names, and then a term. Also, every single function in Torus library has options derived from the Postgres, like from Postgres functions. So you could use them. And also, they do add some overhead to the implementation from Postgres. And for example, in this particular case, you could pre-filter the results. And pre-filtering is fast because you don't need to go through all of them. You could use some indexes, which derives from the way Postgres stores this data, right? And you can pre-filter them, or you cannot. And also, I've picked by default some opinionated defaults for you. So you could actually do something like that, and it will also return reasonable results. And it's, again, a single line of code. So in this example, we are inserting a few users, and then we can search them with a typo, and actually, it works. So we got returned two examples. Then imagine that we have our suggestions, conference suggestions, and we want to search by the body of the suggestion, and maybe the title. So we want to actually, for example, validate if we don't have similar suggestion already suggested, right? So in this case, we have a long text. So it's not reasonable to use similarity search because similarity works best on short strings. And to achieve, to solve this problem, we have full text search. So full text search finds strings that contain these particular terms. It does not tolerate typos, but we don't care about them because we can kind of ignore the vectors that don't match. It supports prefix search, so we can actually prefix search our long chunk of data, which is really cool. And it works by, so we have a sentence, then we remove stop words from the sentence, so the words that do not bring any value to the meaning of the sentence. Then we stamp them to the lexems, so we bring the word into their first form, into the initial form. Then we vectorize them, so we create vectors out of these words. So we append the position of the word in the sentence. So this is also included in the ranking. And then we just compare the vectors, right? So the closer these two vectors are, the probability that these two terms are close to each other and are the same is bigger. And because of that, we return the word. And it actually works really cool. So probably if you open a PDF document and search something there, you will use under the hood full text search. And if you try to find something with typo, this won't work because full text search won't tolerate typos. But prefix search will work. So this is the thing. And we use full text search when we don't care about spelling. The documents are long. And you need to order the results by how close they match what you've inputted. And in Torus, implementing full text search is not easy. So if any of you have done that, you probably know that this will require maybe bringing the whole module with you because there are different steps of full text search. And what Torus gives you is you can, again, in a single line of code, implement full text search, pass all the columns that you need this full text search to be searched through, and pass the term, and it will just work. Also, full text search works best if you have your things that you search through stored inside a vectorized column in your Postgres. And Torus also supports that case. So for that case, you just pass stored true, and then you pass the vector. And it will be blazingly fast, because searching and comparing vectors is blazingly fast, right? But this has some issue. So the problem there is that we don't understand the meaning behind words. So we only match the words, but not their synonyms. What if we want clever suggestions, bodies? What if we want to have clever search? And to have clever search, we have semantic search. Semantic search understands the meaning behind words, and it uses embedding vectors to do that. So embedding vector is a vector representing the meaning of the word in a high-dimensional space. And the closer two vectors are, this probably means that they mean the same thing, right? So yeah, so you can use synonyms in this search. And it works by, you need to vectorize, you need to create embeddings for your data first, and then you need to create embeddings for your term, and then you compare these two together. So you compare your embedding with every embedding for the rows in your database, and then if it's a match, like if they are close, they are ordered, like they are prioritized and returned first. And the caveat here is the more dimensions vector has, the more information it can capture, but then it is harder to compare them. And the lesser information you have, the easier it is to generate an embedding. And I'll show you an example later on that you can generate embeddings on the client, which is really cool because you don't need to have the compute power in your server, and you can delegate generating embeddings to the clients. And we use semantic search really carefully when we need to understand the intent, handle synonyms, and we are okay with being a little slower in comparison to full text search because we need to vectorize your query. We need to create an embedding, an embedded vector. And again, in Torus, it is almost a single line of code. So all you need to do is you need to use a function Torus to vector to convert your term to the embedding vector. And then you need to compare your existing embedding vectors, which you've also created using Torus to vector or to vectors function, with this newly created embedding vector. And then your results will be automatically ordered by the score, by how close these two vectors are. And you might be thinking, how do we generate these embeddings? And that's a really great question because the core of semantic search is not comparing vectors, it is generating these embeddings. And Torus kind of has your back here because it is super extensible on the way you can generate embeddings. So one of the options might be to use some third-party APIs. For example, like Hugging Face, OpenAI, Gemini. And for all these three, it is really easy because Torus already has modules to do that. So you only provide the keys, and Torus will generate the embedding for you and will create an API to do that. But maybe you might want to generate them yourselves. And if you want to generate embeddings yourselves, then you have an option to use, for example, PostgreSML. PostgreSML is a Postgres extension that it is a version of Postgres, which has Python ML libraries included. So you host that on a machine with a GPU, and you can actually do inferring in your database, which is really cool, because you don't need to bring any other services, and you can use your Elixir, which is CPU heavy, and have Postgres be GPU heavy. But if you want to have your Elixir machine be GPU heavy, then you can use local NX serving to do that, which is also provided with Torus. But maybe you have your own idea on how you can generate embeddings, and then you have Torus embedding behavior, which you can implement, and then you can do whatever you want. You just receive a string, and then you return a vector. So there is the contract, and you can do whatever you want. And in addition to that, we have Torus Batcher and Torus Nebulex Cache. And these two models are extremely helpful to make the generation of embeddings a little faster. So the pipeline might look like that. You have your request, then you have a read-through cache, then you have a batcher which will collect a few of the requests, so it's cheaper for you to do the embedding generation, and then you pass the batch to your third-party provider. Then it's returned, it's cached, and returned to the client. And once somebody asks again for the same embedding, you will return from the cache, which is the way it is supposed to work. So this is the ideal pipeline. And also, you don't need to remember anything I've told you just now. You can read that in Torus documentation. You have a guide on how to set up reliable and resilient semantic search and how to add that to your application in Torus semantic search. One key point about actually having search in your app is for it to be fast, because we all love when search is fast and it feels really smooth because it adds the cool touch to your app, and your application just feels faster. So every function in Torus library contains a documentation section on how to optimize your search. So most of the time, you would need to, first, pre-filter the results by either applying some business rules, so you scope the query, the results of the query, to only the things that you need, and you only then apply the search. Also, you can pre-filter by using some advanced techniques related to the search method you're using. Like for full-text search, you can easily, I think for Similarity search, you can easily pre-filter the results because Postgres stores the data in a specific way. Also, you can add indexes, and every search type has specified what indexes can help and how they can help. You can prefer faster terms because some terms are slower, sometimes are some are faster. For example, prefix searching is usually really fast, and suffix searching is not, because, again, of the way data is stored and traversed. And yeah, so again, you don't need to remember anything. Everything is in Torus documentation. And quick demo on how this works. Let me show you a quick demo. Oh, you can see my screen now. Yeah, so there is this application where what we can do, so the first thing that is happening here when you load the page is your model is loaded, like embedding model, the thing that generates embeddings for you, is loaded to the client. So whenever I type something here, I'm using my local embedding model to generate the embedding vector. I'm sending this embedding vector, so this is LiveView. I'm sending this to the server. Then the server takes this embedding vector, creates a PG vector from this, and inserts that into the query and queries the data. So here, I could say that, for example, I want to find something. What do we want to find? Something with nodes. So group my memos. We have the code for that. And you see, it found a post which don't have either group or memos. So this is the only instance of that word. And memo is a node, group is probably node-taking system. So this body was matched by how close the vectors are of the embeddings. And we can see the generated query for that research. We can also toggle and try different search types. For example, we can change the way we compare the vectors. We calculate the distance between these two vectors by using, for example, L1 distance or max inner product. And you can see actually the variables being injected. So we can see live what was changed, and we can configure that. But you might be wondering what search controls do. So in search controls, we can choose and play with every option that I've shown to you before, every search type. So for example, for full text search, we can search by words. So here, let's say, learn common strategies. Learn common strategies. Will this work? Yeah, I think, yeah, it worked. And it excluded other results because they did not match at all. And we can see the query that was generated. Again, a single line of code, post, full text search. It passed title and body, passed our term, and a few options. And these are actually default options, but they are copied from the left bar, so we don't need to div them every time. So this is how full text search works. And for example, you can also use some primitive searches like search. And there, for example, we want to find effective, not effective, but lessons, let's say lessons. And search everything. Okay, it doesn't work. Oh, I know why it doesn't work. Because lesson starts with a capital, and does not treat capitals well, because it actually is not, how to say that? Yeah, so capitals and the other ones are not compared together. Case sensitivity, yeah, thank you very much. Actually, it is written here. So lessons, so this should work now. Yeah, lessons learned from shipping products too early. I think that should be it. I think, yeah, let's come back to our previous view. Yeah, dziękuję. To wszystko. Thank you very much.
Thank you, Dima. Are there any questions? There's one.
So GPUs may be expensive. Is there like a reason? Is there like a use case where I can like if I guarantee that I stay under some threshold of some amount of data is still like performant on CPU?
Yeah, I think yeah. So the problem here is that you can generate embeddings on CPUs, but there is a caveat. The bigger the vector is, the more like computational cost, the more cost is involved in generating it, right? Because the more like the bigger the vector, the more data it involves like in the more context it has, right? So the dimensions of the vector imply how smart and how correctly it represents the reality. But you can actually generate small vectors on CPU. And I think the model I've used here weighs like 25 megabytes, and it's really fast to work on CPUs, but the quality of these vectors are not like the best. And if you have a lot of like data, then it might struggle, but it might work also. So depending on how accurate you want to be with this like synonyms thing, depending on that, you might use different. Yeah, you might use GPU or you might use CPU, so you need to test that.
Thank you.
You said that in the demo you generating the vectors on the client side?
Yes. So the browser is generating vectors.
So that's also a way to save some GPUs on the server.
Yeah. So in the demo, I'm not using GPUs on the server at all. So the client is first fetching the model and then generating embedding vectors on the client. So you don't need GPU on the server at all. Yeah, there is also. Thank you.
Yeah. Any other? There are two more.
Do you have any tips when it comes to like Polish text? For example, is there anything that you have to think about when it comes to that?
Polish language, right?
Yeah. So imagine like you have a lot of couple of millions of web pages that you have like kind of just taking the text from it, and all of them are like Polish web pages, right?
Yeah.
And you want to search and embed through them.
So, yes, I think most of Torus would work, and most of Postgres things would work. But in Postgres, the way they are stored might differ, and the way I'm not sure if. So this is not that easy. And some of the functions won't work, and you would need. But I know that Postgres has extensions to support different languages, and you might like just fetch the extension for for supporting Polish language in these search types, and this will work. And I think actually storing that in the database and then searching that will work. Mainly will work.
Okay, thank you.
You're welcome.
Can we get back to the example with embedding?
Sure. That one?
Yeah. Well, we are creating embedding, and there will be a comparison of the vectors, but where is generation of the vector for the data that we insert?
Yeah, that's a great thing. So this is happening under the hood, and how we can do that? There are like multiple ways, but we can have a trigger in our database if we have, for example, if we use PostgreSML, and then our database can actually generate embeddings. Then we can have a trigger in our database, then when something like when post is inserted, it generates embeddings out of the data and stores it in the embedding column. So this is how I actually tested that. So I have a trigger, and then when something is inserted, then the trigger is called, it takes this data, calls the LLM to generate an embedding, stores that into the embedding, and this works. Also, another way of doing that is, you are probably all familiar with O-Bahn, right? So how we can do that is we can actually trigger, like schedule open job per, for example, insert, or once upon a time, like every, let's say, 10 minutes, depending on how, like, what is throughput of your data. And then you go through the records that don't have embeddings or that were updated in this like timeline, and then you update the embedding vectors for them. So you generate it dynamically, and you have the robustness of the and resilience of Oban in generating that.
Does it require some plugin for a database?
To generate embeddings, right?
Yeah.
Yes. So this is kind of different version of Postgres to generate embeddings on the database. But to store them, you need to have a PG vector database extension to support the format of the vector, because Postgres by default does not. I think, yeah, it does not have it.
Okay, thank you.
No problem.
Any other questions?
Yeah, feel free to. We have a few minutes left.
Yeah, Dima was faster than...
Really?
Yeah, I guess. Anyway, if there are no more questions, then feel free to ask Dima when he's around. And actually, I said at the beginning that we'll have 2 presentations and then pizza, but pizza arrived. So I guess we need to take a break, 10 minutes to grab a pizza, eat or come back, take it back here, and we will continue in 10 minutes.
Cool.
Thank Dima. Let's thank Dima again.
Thank you. Hope to talk to you.
talks in 2 minutes, so please start finishing and coming back to the audience. All right, we're going to start with the second talk for today. So everyone, please take a seat. And Alan, you can set up, I think. All right. So, Alan also works, as after mentioned. He works on Live Debugger, the tool for debugging LiveView applications that you might know. And he likes LiveView a lot, so he put a LiveView in a LiveView, in a LiveView, and in a live component. And then something happened, and he's going to show us how he got around it. So let's welcome Alan with a round of applause. And the stage is yours.
Thanks. Hi, everyone. I'm Alan. And today I will talk about nested live views. And if it's nested live views, it must mean that it's connected to Phoenix LiveView. And we start with a quick recap. What is Phoenix LiveView? Do you have experience with creating LiveView apps or no? Okay. Some of you may have experience. I'll try to explain everything, but you can ask questions if you want. Let's start with live views. Live views essentially are processes. This is an example of LiveView stolen from Hexdocs. LiveView basically keeps your state reacts to your event, like clicking on a page, and then renders correct HTML. And if it is a state, then if it is a process, it must mean that it has a state. And yes, when I've checked sysget_state on the process of LiveView, I have socket, I have components, I have data, I have the assigns which I've mentioned, which are used to render something dynamically. And also, if this is a process, it can communicate with other processes. It has many callbacks. I'm gonna focus on the handle info, which many of you may already know. And yeah, essentially, I want you to understand that LiveView can receive messages. You can use Phoenix PubSub to work with it, and that's great. And the next thing is live components. And the first question is if live components are processes. And yeah, this is the live component. And live components are not processes. They are part of the parent LiveView. So this is how you can put live component into Higgs. And their state is inside the state of your parent LiveView. So if you have a massive LiveView with many live components, all the state is kept in one process. And also callbacks, we don't have any handle info. So all the messages which you want to send to a live component, you need to send via parent LiveView. You may use this send update function and use the update of the live component. This is the quick recap which I wanted to tell you. And leveraging nested LiveView. Let's start with a problem. Imagine that you have a LiveView application, and on your website you want to have some live analytics, you want to have some messages, and yeah, you want to have everything updated. You add PubSub, and you handle every message via handle info. You create your nice, good-looking application, and your LiveView is big. Your things are big, and you want to do the decoupling. You want to split it to the components. You want to handle message passing and extract it to something which you can even reuse later. And what are the solutions? You could use live components, but as I've mentioned, live components cannot receive events sent to via the send function from Elixir, and also cannot subscribe to the PubSub. So you need to do everything inside LiveView. As you can see in the LiveView, you need to add handle info, you need to subscribe to PubSub, and then you need to send update to each live component. And basically, your LiveView is like a router for all the messages, and every message is going through your LiveView process. And if you don't want to add this handle info, you can extract it to some other module and use hooks, not the JS hooks, but the hooks in Phoenix LiveView, which essentially allow you to add function into the lifecycle, and you can define this handle info callback outside of your module to better decouple your code, to make it look simple. But essentially, under the hood, all the messages are going through one process. So there is the nested LiveView. And by nested LiveView, I mean live render, which is a Phoenix function, which allows you to render a LiveView inside other LiveView. Then you have another process. You can You can subscribe to messages, you can send information, you can store your state outside of the parent LiveView, and it may allow you to better decouple your code. So this is a quick example how it might have looked like. So this is just a normal LiveView, but here we are using live render to render it inside other LiveView. And this is an example how you can call this function outside of the LiveView. Okay, and now I'm going to demonstrate an app. I haven't written this app. My friend Szczepan wrote it. And this is basically a messaging app. We have 2 accounts. We can send messages like, hello. Okay, so to better understand what's going under the hood, I will use the live debugger, which was mentioned earlier. And now, as you can see, this is a nested LiveView render inside a parent LiveView. So keep in mind that these are 2 separate processes. Okay. Great. And now let's see all the callbacks which are run. I will filter them so that you will only see handle info. This is the nested LiveView. And here we are looking at the parent LiveView to show you that I'm not lying. Oh, okay. I am going to send new message. Hello again. And let's see. Oh, I forgot to start it. Hello again. Yeah. As you can see, messages are passed to the nested LiveView, and your parent LiveView is not responsible for handling them. So, as you can see in the code base, this is the nested LiveView, and as I've mentioned, we have all handling of the processes of sending messages here. Actually, here. And when you want to use this whole application, both UI, reactivity, handling messages, you just need a few lines of code, and it works. So, are nested LiveViews great, and should you use them always? Actually, no. There are some caveats, and you need to think about them when you want to use them. The first is that live components and components can react to the change of the parent's state. You can pass the assigns downstream, and they will re-render. But here, when you have another process, when you want to change to, when you want to propagate some changes, you need to send the messages. It's great because you have this message passing encapsulated, but it also means that you need to use messages to change the state. Also, a small caveat is that some functionalities like put flash may require you to use your root LiveView, and you need to have a workaround about it. And also, the one thing is that, the one thing is that you have no slots. You cannot do like a generic wrapper. I mean, if you are hacky enough, I think you could try to achieve it. But essentially, when you're creating a nested LiveView, it's one whole component. Like message app, you can have a small message box inside many of your pages. It can be inserted even in normal Phoenix controllers, not necessarily LiveView. But if you want to do something like a wrapper, which only handles message passing, it might be tricky, and it might be hard. And actually, I think I was pretty fast because that's all I've prepared. But if you have any questions, something I can clarify, please ask them.
So I guess time for questions now. Are there any? There's one there.
More like a, I don't know, remark than a question, but yeah, sorry for bringing down the discussion to this level, but JavaScript frameworks have this problem recently. Like all of the JavaScript frameworks basically went into the component-based architectures, right? And for example, getting the data, like fetching something, right? They start to go into the direction that actually component does it, not the page, right? So you have basically something there, right? You can clearly see that, like, it's the zeitgeist, basically. Like people do things like this now, and like also like another thing to think maybe like, have you tried like any workaround, like maybe using iframes for this? Could you be doing like embed one actual route inside the page via iframe, right?
You mean like rendering LiveView inside iframe inside other?
Yeah, like like the page would contain the iframe, and the iframe would be like the different route, right?
Actually, in some previous project, we had LiveViews in iframes, and from my experience, it's not easy to handle it properly because of cookies handling proper sessions, especially when you have some LiveView which needs authentication or something like that. But yeah, iframes may come like a solution, but I think it's not the solution typically for LiveView, but rather a solution for the front-end frameworks in general.
Yeah, because you would hit the same problems, right? Like with the flashes, with the
pop-ups,
for example.
It will. Exactly. You will have the same problems, and I think that since it's already there, why not to just use it?
Yes. Thank you.
Any more questions?
Hello. Hey, so I don't have any experience using LiveView on production, so this may be a dumb question, but how do you handle front-end interactivity? Like, I would imagine that for some things you don't want to reach for the server because of the latency. Like, I don't know, you want to open a model or a details menu. Do you use a front-end framework for that?
Yeah, actually, I think that latency is a huge problem when it comes to LiveView, and the reactivity in LiveView comes from going to the server and updating it on the front end, but you could use something like details for collapsibles. You could use some HTML workarounds, but then you might end up in the different things being on the front end and different things being on the back end on the server. And when you have mismatch, you may have some problems. So I would. It's risky, and sometimes you might end up with big problems when it comes to handling something on the front end, especially with JavaScript, and handling it on back end. And maintaining this synchronization sometimes is really hard.
Yeah, right. Thanks.
Do we have any other questions? If not, let's thank Alan for the presentation. And unfortunately, since Jose couldn't make it today, that's all for the presentations part, but it's the beginning for the networking, discussions, beer, and pizza, so I guess we are not even halfway. Anyway, to everyone who is watching online, thank you for your time. Thank you for being with us remotely. And let's proceed to the second part of this meetup. Thank you.